Calculus. We're looking at note 7.6. This is basically a review. I don't think you're going to find anything new in this section since we're at the end of the chapter. We're looking at graphics. graphics. We're looking at graphs, numerical, and analytical approaches. Given the graph equation or table of values represent the exponential function, state as many facts about the function as you can. Each fact must be numbered, and justification must be provided based upon the information for the function. All right, number one, we're told there is a horizontal shift to the right 2. We don't know what the vertical shift is. We don't know what b is. We don't know what we're multiplying by the inside or the outside. Let's check out the left and right end behaviors. As this fella moves to the left, it looks like these y values are getting closer and closer to -1. So I'm going to state that the limit of h of x as x approaches -infinity is getting closer to -1. What conclusion can we draw from that? That there is a horizontal asymptote at y equals -1. What conclusion can we draw from that? That k is equal to -1. That's the constant. All right, what else? Well, let's check out the right end behavior. Let's go this way. The limit of h of x as x approaches positive infinity. Looks like these numbers are getting super big in the negative direction. So it looks like it's going to -infinity. Since this is going to -infinity, then that tells me that c is bigger than 0. That means that h of x goes away from the horizontal asymptote. And since this is going down, this is exponential decay. Let's see, what else can we tell from this? We're saying there's a horizontal asymptote at -1. All of these numbers here are below -1. That tells us that a has to be less than 0. Let's see. So we know c is positive. We know a is negative. We know what the horizontal asymptote is. We know what k is. That's pretty good. Let's check out another one. This one is a graph. So what conclusion can we make about the equation of f of x based on this graph? Well, let's take some easy things here. Let's go with the limit again. The limit of f of x as x goes to the right forever is going to 3. So what does that tell us? That tells us that f of x has a horizontal asymptote at y equals 3. That tells us that k equals 3. Let's see, just looking at the curve is growing towards the horizontal asymptote. So f of x is going toward the horizontal asymptote. That tells us that c is less than 0. It's negative. We could say that the graph of f of x is below the horizontal asymptote. Conclusion we can draw from that is that a is less than 0. We could say that f of x is increasing. It's going up as we go right. So it's exponential growth. Saying it's increasing doesn't mean it's exponential, but we know it's exponential because it's an exponential equation up there. Check out the third one, just looking at it analytically, which means looking at the equation. What conclusions can we draw from this? Well, we could certainly say that k is negative 2. Therefore, g of x has a horizontal asymptote at y equals negative 2. We could certainly say that a is less than 0. A is negative right here, negative 1 to be in fact. So that conclusion we can draw is that g of x is below the x-axis. I'd rather have this written with the coefficient of x to be 1. I'm going to factor a negative out of the numerator. And from this, I could say that c is less than 0. Therefore, let's see, g of x goes toward the horizontal asymptote. That means that we have a limit of g of x as x goes to the right is going towards that horizontal asymptote of negative 2. We could say, since both of these are negative, g of x has 2 reflections. Based upon that, g of x is exponential growth. We could certainly say that the graph is translated to the left 3 and down 2. That's from the parent graph as a reference. All right, we will stop this video and we'll do one more, given a table and answering a bunch of questions about it.